Hello, my name is Prathamesh Shailendra Shirsagar. I am from B division. My roll number PRN number is 121B1B 129. I am from Computer Vision 3 division. So my topic for FA2, that is formative assessment 2, is uh, pneumonia detection and brain tumor detection. Basically, I have made a website of training models using CNN VGG16 and the model like GAN. Using this, I have trained the models and have saved that models. Use that models to make a website, the website which will make the change in the future, the website which is helpful for the people like us when we if the people want to look for detect their brain tumor early as possible, so they do not have to wait for the line as they were waiting as of now. So I've come up with a website. I've built a website which basically detects 7 diseases. For of now, for FA2, I have made up 2 diseases, that is brain tumor detection and pneumonia detection. The 7 diseases that the website will detect are COVID detection, then brain tumor, breast cancer, then Alzheimer, then diabetes detection, then pneumonia detection, and heart disease detection. These all 7 diseases are the crucial diseases and needs to be taken care very thoroughly. So starting with our code in this. Firstly, we have imported the libraries for the CNN model and then imported the libraries for the VGC16 model, which includes the Keras application. And also, secondly, we have done the train test split. The train test split we have done in groups like for validation, the train set, then test set. The first 5 images are copied in the test directory. The 80% of the remaining images are copied to the train directory. The rest are copied to the validation directory. So after that, loading images are I have written the function for loading images, which loads the images into the array. Uh, I have also written the function for the plot confusion matrix, plot for the plotting purpose of the confusion matrix. After that, the loaded image from the array has been displayed over here. So it has taken 193 images from the train directory, 10 images from the test directory, and 50 images from the validation directory. After that, I've plotted the graph for the train for the comparison of the count of train set, validation set, and test set. After that, I've taken the count of all the images where the tumor is present and where the tumor is not present. As we can see in these images, there are various edges in that. So cropping the images, applying the Gaussian blur and threshold, giving the images a threshold. We have cropped the image successfully, and we can see over here the cutting edges has been seen are been seen over here. So there are two types of images that are tumor that the images that contains tumor and the images that does not contains tumor. So these images are stored in the folder called yes and no. So this folder is locally saved into the local machine. After that, I've done data augmentation. The data augmentation process is used for the we can say the distribution part. So after that, I've learned the model with the CNN, that is convolution neural network. The convolution neural network is a deep learning model where it is used for image recognition, medical imaging, and video analysis. So here, as we can see, there is a function for train data generator and test data generator. These two functions are very necessary because the train data generator applies various random augmentation to the images, and the test data generator does not apply augmentation, but it only pre-processes the images. After that, we can see over here the VGG16 model. The VGG16 is an specific type of CNN architecture. So in VGG16, it is basically used for image classification, object detection task. It is often used as a pre-trained model of CNN. So for fine tuning, it is used in the CNN model. In the VGG16 model, there are layers. So in that layers, the first top layer is the flattened layer. In the flattened layer, the flattened layer is added to convert the features into one-dimensional vector. The second layer is the dropout layer. It is added to prevent overfitting, and the last layer is the dense layer with a sigmoid activation. It is used for binary classification. For our purpose, we have used it for 1 for brain tumor and 0 for no brain tumor. So we can see over here the total parameters used and trainable parameters and non-trainable parameters. I have also printed the history of the model, how the model works. So at the first epoch, we can see the loss of 11% and the accuracy is 61%. So traversing up to the 30th epoch, we can see over here the loss is reduced to only 1% and the accuracy has increased up to 91%. Also, I have printed the graph for the accuracy, that is model accuracy and model loss based on the epochs. I have also printed the confusion matrix, which tells us that our model is best for our website. So also I've written a function for a wrong prediction. It just gives us if the images are wrongly predicted. Here we can see there this image contains a brain tumor. The actual class is 1, but the predicted class is 0 over here. Then the third model I've used is GAN. GAN is a generative adversarial network. The GNN are the class of neural networks that involves two networks competing against each other. So the two networks they used are generator and discriminator. The generator tries to create fake data that looks real, but the discriminator on the other hand tries to distinguish between the real and the fake data. So here we can see that for the uh, GAN model, we have written an generator class and discriminator class. So for that generator and discriminator class, we have given the hyperparameters. After that, we have loaded the dataset, the brain tumor dataset over the generator and discriminator. We have passed the dataset in the generator and discriminator, and after that, we have printed the in for each epoch, we have printed the loss, the accuracy, and the output. So thank you. The front page of the website. As we go in the brain tumor detection, we have to put the patient's name, then the last name, then the phone number. It is based on validation, so you have to put the phone number over here and the area code. Also, you have to put the Gmail over here. So select the gender if he is a male or female, and put the age. What is the age? So if you you should have a brain MRI with you. So I will be selecting the I'll be selecting one image. So this image I have selected and submitted. So yeah, so this is the brain tumor test results where we can see like the name, the last name, the information we have put, and the result that tumor exists. So if the tumor exists, so the patient should directly visit to the hospital and take the preferred treatment. Also, I will be showing you the pneumonia detection. Also, putting all that things, all the required first name, last name, and the gender and the age. Also, I will put the chest scan over here. I have one chest scan which I used for training the models. I will show you. Yeah. So I have one. So putting it. Yeah. So as we can see in this image, this part is very infected. So and the result is also positive. So we can say our model is well trained and good to go. So this is my project. Thank you.